Great, thanks, Bronwyn. That's really great. All right, yeah, so I'm Randy Shoup, and I want to talk to you today about minimal viable architecture. So thematically, very similar to the talk in this room just a moment ago, there's really no one perfect architecture for all scales, for all phases of evolution, and for all problem domains. This is pretty obvious, but like I think sometimes we have a little bit of envy of other people's architectures and try to think that we should do them when we should really be solving our own problems. So the kind of structure of this talk is about, let's talk about the different phases of companies and products. And I think all products kind of go through this S-curve, and we're going to have we're going to notice that there are different architectures that are appropriate at different levels and different scales of the company. So a little bit about my background. So most recently, I was VP of Engineering and Chief Architect at eBay. I also spent a bunch of time at eBay as an individual contributor earlier in my career. I've been an engineering director at Google for Google App Engine in the early days of Google Cloud. I ran engineering at StitchFix, which is a clothing retailer in the United States, up to and through the IPO that we had. And then I also worked as an engineering leader at WeWork up to our not IPO. In case anybody's heard of that. Happy to tell stories over adult beverages about that, because the stories are crazy. I am for startups, I advise a bunch of startups, and so a lot of times I'll have conversations that'll go like this. They'll say, tell us how you did things at Google and eBay, and I will say, sure, I'll be happy to tell you what we did, but you have to promise not to do them yet. And the reason here, obviously, is that the stuff that's appropriate for a 5-person company is not the same thing that's appropriate for a 50,000-person company, and vice versa. Okay, so I want to start a little bit about talking about some architecture evolutions of eBay and of Amazon, and then I want to go through, as I talked about, those different phases of companies and talk about what the appropriate architecture might be. So eBay started famously about 27 years ago as a 3-day weekend project of the founder. So he spent the Labor Day weekend playing around with this new cool thing called the web. He built the first thing that ultimately became eBay in Perl. So every item was a file. I like to think of that it all lived on his little 386 tower under his desk or something like that. And it didn't scale, but it wasn't intended to. The next iteration of eBay's architecture was what they cleverly called V2. And it was a monolithic C++ DLL that plugged into the Microsoft Internet Information Server. So if you can remember that, you're old just like me. So it was a C++ DLL in there, monolithic. It grew at its worst to 3.4 million lines of code in that single DLL. That single DLL. They were hitting compiler limits on the number of methods per class, which I'm embarrassed to tell you that I know that the Microsoft compiler at the time allowed 16K methods per class. And they were hitting that limit, super scary. So you can imagine that this was really difficult to work in, and there wasn't much ability to move quickly. It turns out that for the engineers, they were all not only in the same repo and not only in the same file, but they were actually all in the same class. That was why we were hitting those compiler limits. Pretty brutal. So the next iteration was, again, cleverly called V3. And this wasn't yet microservices, but this was a breaking up of that monolith into what I would call Java mini applications. So several hundred different aspects of the site. Each part of the site was built or shown by a particular one of those applications. So you'd have an application for the search part of the site, for the selling part, for the buying part, et cetera, and you aggregate that all up, and that was eBay. And then there were a bunch, this will come into play later, but there were a sea of shared databases underneath that were used by a lot of those different mini applications. And then the more modern iterations of the architecture, because there have been 5, or more microservices, and again, still Java, but moved to Spring, and then a move to Spring Boot. But this is how eBay architecture has evolved over time. Amazon has gone through a similar evolution. So it started in about the same time in 1995. It was its initial monolith was called Obidos. That's a city on the Amazon, in Brazil. It was a monolithic Perl and Mason front end over a C language back end. The application was a 4 gigabyte application, so at 4 gigabyte worth of application in a 4 gigabyte address space. So they were regularly swapping just the application in and out of memory, pretty brutal. They were regularly breaking the GNU linker, and because it was so, I'll call it effective at leaking memory, they were having to restart the service every 100 to 200 requests just because of the memory leaks. And as a consequence of this painful situation, they were actually ending up being able to release once a quarter. During the years 2001 to 2005, they went through a massive migration to services, what we might now call microservices. Wrote those services in the newer languages at the time, C++ and Java, or more modern, I suppose. No shared databases, though. So, an edict from Jeff Bezos was like you couldn't share data in any way, which was really great. And then, in case anybody wonders whether architecture matters, like after they completed that service migration, the very next year, AWS launched, and Amazon started their kind of inexorable takeover of the world's online retail. So architecture really matters. Okay, so what can we learn from these two stories? The first one is that no one starts with microservices, but past a certain scale, everyone at these large scales ends up with something that we would call microservices. But the other point I think here is that most never reach that scale. So it's pretty important for us to understand what the problem that we're currently solving at our company, as opposed to envy of the larger places. The other way I like to say it is, if you don't end up regretting your early technology decisions, you probably over-engineered. There may well have been another company in 1995 that could have been an eBay and Amazon competitor that, instead of building a monolith and solving customer problems, instead they built a distributed system. And there's a reason why we've never heard of that company. Okay. The structure from the talk going forward is I want to talk about the phases of products and companies, and then talk about what are the appropriate kind of patterns and forces at each of those things, which will tell us what kind of architecture we need to have. So let's start with what I like to call the idea phase. So this is before we've written any code. What is the thing that we're even trying to build? And if you take nothing away from this talk, I guess I would ask you to take away these 7 words, because they're so powerful. What problem are we trying to solve? So this is the question that we're asking ourselves at this idea phase. What's the problem that we're trying to solve? Is somebody willing to pay us money for it? Is there product market fit for the solution that we think we might want to do? And why is this so important? I'll just lean on Mary and Tom Popendick in their excellent book, Lean Software Development, because building the wrong thing is the biggest waste in software development. So we really need to understand our problem in order to avoid building the wrong thing. The other quote that I like on this line is from Charles Kettering, who used to be the head of research at GM. A problem well stated is a problem half solved. So if we can be very clear on our problem, we're well along our way. Okay, so at this idea phase, the way I would suggest that we look at architecture is everything is a prototype, right? So our goal here is to explore the potential problem space that we have as rapidly and as cheaply as possible. We want to find a business model, we want to find product market fit, and we want to acquire our first customers. And so the goal here is rapid iteration. So everything that we build here is going to be a prototype, and we're definitely going to throw it all away, whether we think we're going to do that or not. So ideally, we'd have no technology at all, right? So there's a reason why user experience designers use paper prototypes. That's because we can rapidly look at potential ideas and literally throw them away if they're not good ones. The clever idea out of the Lean Startup book is, if you want to do online pet food, start some fake Google ads and see if anybody clicks on them. In the early days of StitchFix, which ultimately grew to be huge investment in data science and machine learning, the original implementation of that fancy algorithm was an Excel spreadsheet that the founder wrote. So again, ideally no technology at all. A WordPress blog would be another great thing to do at this stage. So the way I like to think about it is engineering is about solving problems, and only sometimes do we solve those problems by writing code. When I was leading engineering at StitchFix, again, it's a clothing retailer, so we had physical warehouses around the United States. And one of my teams built software for the people who operated the warehouses. And a lot of times they would come to us and they'd say, hey, can you please add this button or do something to the existing applications to help us do our job. And once we started to get into it with them, a lot of times we could figure out that it was actually more appropriate for us to change the business process than it was to change the software. We'd be very happy to change the software. We're happy to add buttons all the time. But by looking holistically and not always assuming that the first thing that we do is write software, we were able to build better solutions ultimately that mattered to the business customers that we had. Okay. So we talked about the idea phase. Now I want to talk about what I'll call the starting phase and what characterizes the starting phase, so that we have one team. So maybe we're 5 people. We all fit around a conference table, and we have a pretty short time horizon, right? So we don't necessarily know that we're going to exist 1 year, 2 year, 5 years down the road. So we definitely shouldn't be building technology in order to solve problems that we only are going to have 1 year and 2 years and 5 years in the future. So the kind of architecture that we want to have in this phase is what I'll call just enough architecture. So we want to meet our near-term evolving customer needs as cheaply and as simply as possible. We want to delight those first customers that we've hopefully acquired, and we want to acquire more. So here, the goal here is for us to do rapid learning and improvement. We want to prioritize team productivity over really any other thing, and this is definitely not about scaling, right? So this initial phase is not about scaling very large because we're not large yet. So one of the quotes that I like in this area is from Martin Fowler. So the best code we can write now is code that we'll probably discard in a couple of years' time. So what would just enough architecture look like in this starting phase? So we want to use simple and familiar technology that's familiar to the development team that we have. We want to prioritize expressive power and ease of use for the developers. And this is why a lot of the startups that ultimately become successful start with these kind of rapid prototyping frameworks like PHP or Ruby on Rails or something like that. And that's because it doesn't optimize for where we end up later necessarily, but it does optimize for our ability to prototype very, very quickly. And so here's where we think the monolithic architecture is appropriate. And this is the previous talked about how they started in a monolith, and I would recommend everybody do the same. So single application, single database, and basically no infrastructure, right? So what we want to do here is ideally something kind of like platform as a service, where we build that monolith on top of that. So the architecture diagram, such as it is, and apologies to Simon Brown in the room. It's super simple. Like we shouldn't try to get too fancy because our problem statement isn't too fancy yet. So what are all of engineering is about trade-offs, and so what are the trade-offs that we have right here? So there are some good things about a monolithic architecture, even though it's a slur a lot of the time. So it's simple at first, right? Anytime we're communicating with different parts of the system, the latencies are in process, so everything is a lot faster than it would be if there were a network involved. It's typically a single build and a single deployment unit. That's almost the definition of a monolith. And then it's pretty resource efficient at small scale, actually. But of course, there are a bunch of cons, right? So as our team grows, the coordination overhead of being in the same monolith, grows with the team. There's poor enforcement of modularity, right? To the extent that there's modularity within the monolith, it's because we've had discipline around it as opposed to, being essentially forced through barriers to be modular. There's very little opportunity for us to do horizontal scaling at this point. And then it's also, again, by definition, the monolith is a sort of single point of failure and a single performance bottleneck. So what you'll notice is that these cons are all things that happen at scale. And again, we're in that starting phase, so we don't really have any of these problems yet. So it's a pretty good bet for us to stick with a monolith in the early days. So other things that I think are appropriate at this scale of architecture include really prioritizing buying stuff and taking from other people's software rather than building it ourselves. So we want to make sure that we're spending that we're prioritizing leveraging a bunch of cloud infrastructure, which of course would be a lot faster, a lot cheaper, a lot better than we've been able to do ourselves. And then, the companies that are like this, StitchFix and WeWork in my example, have no physical compute infrastructure anywhere in the world, so just completely in the cloud. We want to prefer open source. So usually the open source technologies, particularly now, are even better than the commercial alternatives. So we definitely want to make sure that we're optimizing for leveraging other people's work rather than building things ourselves. So along those lines, we want to make sure that we're leveraging third-party services as much as we can. So leveraging things for infrastructure like logging and monitoring and alerting, leveraging authentication providers, leveraging other services for things like payments and billing and fraud detection, et cetera. And again, what we're trying to do here is focus on our core competency and use third-party services for absolutely everything else. But there are a couple of things that we can do to make our monolith better, and then we're going to talk about where we go from there in a moment. So the first thing that I would say here is enforcing within the team what I'll call a modularity discipline within the monolith. So I think it's really important that we, even though there's no enforcement of that modularity through like the physical structure, that we do that as a discipline within our development team. And to the extent that we use modules or shared libraries essentially within that monolith, it makes it easy to modify and replace them, and it also sets us up well for the future when we want to break this up. The other thing that I think is really important here is spending a lot of time on detailed logging and instrumentation. So particularly in this phase where we're rapidly iterating, we want to make sure that we understand our user behavior really deeply, and that allows us to understand what problems the users are facing and what solutions we might be able to offer them. And then obviously also from a just kind of like operational perspective, enabling a better diagnosis and better recovery when we have more logging and instrumentation. So the other thing that I think it's really important to prioritize at this stage is making sure that we're able to iterate rapidly and update the software quickly. So again, we want to make investments in continuous delivery. So that would be making sure that we invest in a repeatable deployment pipeline where we have a low risk push-button deployment that tells us whether it's safe to move on. That allows us, even within this monolith, to have like a rapid release cadence, allows us to rapidly roll forward, rapidly roll back, and rapidly recover. It also ends up giving us a much more solid systems. It allows us to release smaller units of work, as we learned about in the keynote this morning. It gives, and if we have smaller, it allows us to have smaller changes that we roll back and roll forward, which gives us the ability to like repair things more quickly, understand things more clearly when we make changes, and then it's simpler to diagnose when something goes wrong. The last idea that I would want to add here is feature flag. So as we all know, it's the capability of adding a configuration flag to enable or disable a feature for a particular set of users. And it's been around for many, many years, of course. Now we can buy them as third-party services, which is great. And again, it's another tool in our toolbox to have us develop more solid systems. So we can decouple code delivery from feature delivery. We can rapidly turn things on and off for either business reasons or operational reasons, et cetera. And it allows us to develop and test and verify our system in production. And then the last thing, obviously, that's really important for this is that, particularly again, as we're doing all this iteration, is we want to do experimentation, again, as we heard in the keynote this morning. And so it's important. So the ability to show things to some users and not other users allows us to experiment in a statistically valid way. And why is that so important? Well, I wonder if people have heard this statistic. So Ronnie Kohavi, who used to run experimentation at Microsoft and at Amazon, and I think now he's at Airbnb, learned this. So it turns out that at Microsoft, they looked at the features that they produced and were they good or neutral or poor. And it turns out that 1/3 of the features that they produced were in a positive direction and were statistically significantly positive. But 2/3 of the features that they produced were either flat, no difference, or they were statistically significant in the negative direction. So this is a really sobering thought that we really need to make sure that we're even though we might think that the feature is particularly good that we want to release. I mean, obviously that's why we're doing it. But 2/3 of the time we're wrong about that. So we need to make sure that that we give ourselves the operational and software tools in order for us to experiment quickly and notice when things are good and continue to do more of those, and notice when things are flat or down and do less of those. Okay. So now let's move on to the next phase, which I'll call the scaling phase. So now rather than one team, we're several teams, and we're growing and adding more teams. Now we have a longer time horizon, so it actually makes more sense for us to invest in longer-term approaches. But again, if I look overall at like the number of applications that are in this, in the world, like it's a pretty small percentage that are actually going to benefit from the things that we're going to talk about going forward. So maybe the first question is, what are the warning signs when we're running out of gas in the monolith? So the first one that I've seen in my personal experience is what I'll call feature velocity. Like our ability to rapidly release new features sort of ends up slowing down and ossifying. And so our time to market is slowing down. Teams are stepping on each other's toes because they're in the monolith, and they're no longer able to develop independently. And then the other kind of related warning sign is that when we're bringing new engineers onto the team, is it difficult for them to be productive, right? Like if they're able to show up and be productive pretty quickly, okay, we have a great modular system. If they have to understand a lot of interdependencies and a big ball of mud, like that's an issue, and we need to make sure that we deal with it. The other reason that I've often seen in terms of rearchitecture is simply scaling, right? So when the vertical scaling of the monolith runs out of gas and it no longer gives us enough to continue to keep up with our rapidly growing site, and parts of the system need to scale faster than other parts of the system. And then the last thing, which is rarely alone, but is usually in combination with either or both of the velocity point or the scaling point, is that parts of the system want to be deployed independently, right? So the monolithic release is too slow because it bundles everything up together. It's too complicated or it's too risky. And so we might ask ourselves, like, why are we redeploying the authentication system every time we update the JavaScript, right? Like that would be pretty silly. Okay, so a lot of times people are like, well, why didn't we just build it right the first time? Right? Like, why didn't we just build scale in from the very beginning? And the way I like to think about it is getting to re-architect a system is a sign of our success rather than our failure, right? Like, why are we re-architecting? It's because people care, and because the initial things that we did are no longer keeping up with, the usage and the growth and the scaling of the system. So again, I think re-architecture is a success measure, not a failure measure. Okay, so when we say scalable architecture, what do we mean? So our goal here is to stay ahead of this rapidly growing business, and we want to keep the site up or keep the app up. Now it's about scaling the teams. Now it's about scaling the technology. And now it's about introducing repeatable processes that allow us to continue to do things in a scalable and repeatable and reliable way. So our organization starts to look something like this, right? So we have a bunch of individual teams, each of which we want to make sure are independent of each other, and each of them are able to iterate quickly and make lots of improvements to the software. So each one of those teams is, to borrow a phrase from the excellent Team Topologies book, each one of those teams is a sort of stream-aligned team. So each one of those teams is going to build and maintain hopefully a single service and application, or a small set of related services and applications. We want to make sure that those teams are able to design, to deploy, to operate their systems all independently of the other teams. And we also want to make sure that those teams own the services and applications that they build all the way end-to-end, cradle to grave. And so what does this imply about the architecture, given that now we have a new set of goals and a new set of constraints, right? So now we want to move to technologies that scale, right? So now it's common for companies to potentially change their language from the old prototyping frameworks to something that's more I don't know, enterprise class, if you like. We really need to, now we're starting to pay attention to latency and performance, and now we want to start introducing capabilities of asynchrony and event-driven capabilities. Now we want to start introducing what I'll call independent systems. So here's the phase where we're introducing fit-for-purpose systems like custom analytic systems or like rather separate analytic systems, like a separate search. Now is the time when we're starting to build or leverage separated services, and usually it starts with money for a lot of reasons, right? So breaking out payment systems and so on like that. And then also we're going to be in a situation where we're going to start layering those services. And then very similar to the talk that we just heard about event-driven, about migrating to event-driven architecture, this is the time where we're going to start to introduce something like that, some kind of event queue or message broker or something like that, that allows us to use messages to communicate between the separate applications and services in our overall architecture. And then the other aspect here is we want to start introducing scalable persistence mechanisms. So we're going to talk about this in more detail in a moment, but like, to the extent that we have a monolithic database, we're going to be breaking it up or figure out how to do that. We're going to be functionally partitioning the database into parts that serve one part, one set of entities, and other part with serving another set of entities. And then sharding these things is an appropriate thing that starts to happen now. Okay. So now we're in the microservices world, right? And so just super briefly, I want to make sure that we're all talking about the same thing. So to me, a microservice is a service that serves a single purpose. It's got a simple, well-defined interface, and the individual services are modular and independent. And then a critical aspect is that those microservices own their own persistence, right? That the only way to get data into or out of a microservice is through the front door, through the main service interface, and there's nobody who has a back door to our database or our data storage mechanism. Okay, just like in the monolithic architecture, the microservice architecture also has pros and cons. So the pros here are now each individual unit is simple. We can independently scale those individual service units. We can independently deploy those service units. That's one of the reasons why we moved to this architecture. And then we have the option to choose a separate technology stack if we so choose when it's appropriate for particular services separate from other services. And then also, I think less appreciated than it should be is individual services become their own security and compliance boundaries as well. So that allows us to isolate the parts of the system that deal with managing money or managing personally identifiable information or managing fraud detection or something like that. So the service mechanism gives us that modularity to be able to bound the parts of the system that do the complicated or scary or compliance-related stuff. Okay, but it's not all rainbows and unicorns, right? So microservice architecture has a bunch of cons. So now, even though each unit is simple, now we have multiple cooperating units. We've exchanged those in-process latencies for network latencies. Now we need to introduce much more sophisticated deployment and monitoring capabilities, and arguably the overall system complexity, at least from a boxes and lines perspective, is higher in this microservice world than it was in a monolithic world. Okay, so now I want to spend a little bit of time talking about, well, how do we get from there to here, right? So how do we get from a monolithic architecture to a microservice architecture? And I'm going to give you a couple of different ways of looking at that problem, all from my experience, where sometimes I've done it well and sometimes I've done it poorly. But I think what I would universally say is, again, to quote the wonderful Martin Fowler, you definitely don't want to do a big bang migration all in one go. So the only thing a big bang migration is a big bang. The only thing it guarantees, rather, is a big bang. Okay, so the first slice or dimension of this migration that I want to talk about is doing it incrementally. So when you're in a situation as eBay was, back in that horrible V2 ISAP EDLL with a 3.4 million lines of code. The first step, or the step 0, as I like to say, before we do one of these, as we do one of these migrations, is pilot out building something in the new system so that we can figure out whether it works and optimize for learning and learn really quickly how to do it well and how to do it poorly. So I very advisedly am using the term pilot here rather than prototype, because we want to select something that actually matters to our users. Usually I recommend taking a particular end-to-end vertical experience, whether it's some new thing or some existing thing, and we build that entire part of the system in the new way rather than in the old way. And why do we do it that way? It's because this is our opportunity to optimize for learning, to learn and adjust in the new architecture approach. We need to prove to ourselves that it's going to work, so it allows us to demonstrate the feasibility and allows us to gain confidence in that we can do it. But it also allows us to focus very clearly on one particular area, so we don't have to solve all the problems around the entire aspect of our system, but solve problems that are just targeted in one particular area. And it also bounds our investment and risk in case it doesn't go particularly well the first time. And this initial step is really the hardest, right? So we're learning to do things in a new way. Again, in the last talk, it was the team learning how to do things in a microservices way when they were used to doing it in a monolithic way. And also, by its nature, we're having to build out a bunch of supporting capabilities in order to get this to start up. And once that pilot is successful and what we've learned from it, now and only now should we start rolling out this migration and start attacking the rest of the system, the main part of the system. So the way I like to approach this is a little bit counterintuitive. So I like to again, because we've de-risked it and we've done the pilot, now we know that it's going to work. So now I'm thinking about, for this, how can I maximize my ROI in terms of the investment that I'm making in this migration? So I actually would often recommend prioritizing the biggest bang for the buck things first. And that allows us to maximize the near-term payoff from that limited investment or finite investment that we're going to make in this migration. And it also forces us to confront and solve a bunch of harder problems earlier rather than later in the time. And actually, that's exactly how eBay did its V2 to V3 migration, actually. So again, they did a pilot, and then they actually reverse sorted all the pages on the site by revenue contribution, and they started migrating the ones that were the highest contribution. And again, that seems a little bit crazy, but the reason that we did it that way was because those are the areas that really matter. Those are the areas where if we can get them on the new architecture and allow us to change really quickly, then that's going to give us a lot more value as a business. Okay. While we're doing this migration, you can never avoid doing new feature development in parallel, right? So it would never be correct for us to say, sorry, business, for the next, quarter, year, 2 years, no more new features, thank you very much. That would be deeply wrong on a bunch of different levels. So we really can't pause the feature work. So the way I like to think about it, though, is within any particular component, any time that we're releasing something, that deployment should either be a feature change holding the kind of migration constant, or a migration change holding the features constant. Does it make sense what I'm saying there? Because we want to make sure that we're only changing one variable at a time. And the worst thing that we can do is migrate a part of the system to the new architecture and also do feature changes in it at the same time. Because then when, not if, something goes wrong, it's hard for us to unpack whether it was the migration and the architecture or it was the new feature that we did. Okay. And then this comes from my experience at eBay and other places, but it turns out that there are residual components of that original architecture. They might remain indefinitely. There were years after the V3 migration was supposedly done at eBay where there were still a few pages that were served by V2. But again, because they did it kind of in in priority order, and like in the reverse order of revenue contribution, reverse sorted by revenue contribution, the stuff that remained was like not that interesting and not that difficult and wasn't changing very often. So it was, there wasn't a lot of business case for us to continue to finish those things on a super fast cadence. Okay. So now the other aspect that I want to talk about in terms of migration is two different patterns for how to do a monolith to microservices kind of transition. So the first one is when we have the problem of a monolithic application. This is the way that I approach it, and I found success with this. So the first thing that we want to do is we want to look for or create what's called a seam in the monolith. And I just love Michael Feathers in his Working Effectively with Legacy Codebook talking about seams when we're doing migrations and reimplementations. And often it's the hardest part because we might actually have to do a bunch of work and refactoring in order to create this seam. But we found a seam for the particular area that we want to pull out. Now we want to wall that off behind an interface. So like whatever language or framework that we're using, whatever your interface mechanism is, like wall that area off behind an interface, and the only way to get in and out is through that interface. Now we want to write automated tests around that interface. Please don't skip this step. If you do, you'll be in for a world of hurt. Ask me how I know that. In fact, when I started in this industry, I had hair. So there you go. OK, so please write automated tests around that interface. That's why we spent the effort to find that seam and to build the interface. Now and only now should we feel safe to replace that in-process implementation with an independent component. And then now we can start to do rinse and repeat, right? We'll do that for another part of the system, another part of the system, another part of the system. Does this make sense? OK, cool, great, lots of nods. OK. This is if we have the monolithic application problem. And there are other patterns too, but this is one that I've used more often even than the strangler pattern. Now if your problem is the monolithic database, here's a way to kind of help migrate that to services. And so the example here was some work. It was a bunch of work that we did at StitchFix in order to break up the monolithic database that we had. So the problem is that we had a bunch of different applications and services all leveraging the same shared database. And you can imagine that shared database is a single performance bottleneck, a single point of failure. It's a challenge. Who has worked with architectures that look like this? OK, quite a lot. All right, I don't feel so bad. OK, so what we want to do is we want to decouple those applications and services from that shared database. So let's just to keep the boxes and lines clean, let's imagine we have 2 applications and 3 tables rather than 100 applications and hundreds of tables. OK, so the first thing that we want to do is we want to create a new service that's going to cover a particular consistent part of the coherent part of the database. So in this example, we're going to move out client capabilities. That's what we called customers at StitchFix. So we're going to create the client service. And now we're going to spend time, and there's an investment here, to move all the applications that were directly using that table in the monolithic database and move those to use the service. There's probably a bunch of iteration in here, and there's definitely a lot of work. So just because I can flip back and forth, it's not so clean, and I'm not implying that it is. But this is the next step. Please do not stop here. You laugh. But when I showed up at StitchFix, they had already been doing part of this migration, and every single thing that they had migrated had stopped at this phase. Why do I not want to stop at this phase, Randy? Well, it's because we have all the problems of a distributed system, right? Because we have this service, and now we're going over the network to the service from the application. We have all the problems of a shared database because we haven't moved any of the data, and we've gotten none of the benefits of microservices. So this is one of those examples in migrations where it starts out at some level of good, and you want to get to some level of better, but you actually have to be worse for a little while until you can, get better and reap the benefits of the hard work that you've done. Anyway, so please don't stop here as we had done. So now the next step here is for us to take, so now that only this client service is using the kind of constellation of tables that are around clients in this database, now and only now can we move those out into a isolated, or I'll call it private database that's associated only with a service. And now we just rinse and repeat, right? So again, there's a lot of work associated with this, but now we do that with, in this example, items. Now we do that with styles or SKUs. That's like the metadata about the inventory that we have. And then the last thing that I want to point out here is that really when we talk about the service, these are the boundaries, right? So the boundary is not just the application part of the service and the code, but it also includes, again, as we were mentioning before, it also includes any data storage associated with that thing. And this is really the boundary that we want to keep nice and isolated and clean and modular. OK. So that was the scaling phase and how we could migrate from the monolithic architecture that we had at the starting phase into the microservices architecture that's more appropriate at the scaling phase. Now I'll briefly touch on what the last phase is, what I'll call optimizing. So here's where this happens, right? We were growing really quickly, and now maybe this particular product line is starting to flatten. And we want to be able to make more investments in other parts of the system and other parts of the company. So we're kind of, are in the sort of optimizing case. So here's where we have fewer teams. We probably have a longer time horizon even still, because we're just going to continue on with this. And so the appropriate kind of architectural changes that we might make here are all about stability, right? So we want to take a system that's mostly stable and not changing really quickly. We want to make it more sustainable, more efficient, and more effective to maintain. So we want to be able, maybe want to make sustainable and incremental improvements in functionality, but there aren't going to be maybe a lot of them, or at least at the same level as we were doing before. And now we also want to make sustainable improvements in operational efficiency as well. And then we're probably thinking about consolidating the teams, because again, we don't need the same level of team investment as we used to, and we can put a bunch of people on newer stuff that are earlier in those S curves. OK, so as a quick sum up here, when we're in the starting phase, we're usually a single team. We want to optimize for rapid iteration, and the appropriate architecture there, I would claim, is a monolith. In the scaling phase, now we have many teams. We want to optimize for velocity and scalability, and the appropriate architecture there, I would claim, is a microservice architecture. And then in the optimizing phase, we're more consolidating, so we have fewer teams. We're motivated by efficiency and sustainability, and we're trying to consolidate the architecture to make it easier to maintain. OK, well, thank you very much, and I look forward to some questions.
And we've already got some. I'll just bring the mic over for you.
Can you elaborate a little bit on the consolidating the architecture at the optimizing phase?
Yeah, sure. In cases where I've seen it, sometimes teams will combine. Let's imagine in our microservices phase, we had tens of services, and services tend to kind of accrete over time, and the team wants to be able to manage things more effectively with a smaller amount of resource investment. So sometimes services will get combined, or they'll go out of their way to retire particular services and make things a lot simpler. Does that make sense? What you're asking? Yeah, that's what I'm talking about, consolidating, just making it simpler to maintain. Yeah.
Thank you. Any other questions?
For a bigger company that's already gone through to the optimization stage, if they, I don't know, are branching in a new sector or whatever, do you kind of start back from the start with that new team where you go back to Rails and just, or do you just try and go from that optimize and branch out that way? On how do you balance that?
Yeah, sure. I'm always, this is not exactly your question. I'm always a believer in that idea phase, that we do it in the simplest, cheapest way possible. But no, I don't recommend that Google building a new product that they start with Rails or something like that. Yeah, I think once you're, it's why you're asking the question. Once the company is in that kind of scaling phase, it's a lot easier to just to continue to leverage the service architecture that we have. And actually, if anybody wants to come to my talk tomorrow, I'm actually going to be talking about in more detail, what does it look like in those large-scale architectures. So there you go. Thank you. Good question.
Anyone else? Down the front.
Hi. Just a little bit of interesting how you do with the feature toggling, because sometimes the feature could be big, sometimes it could be small, sometimes it could have a very drastic impact on the system, sometimes it's just a light touch. But what if most of the developers in your team feel like we need to go with a bing bang, because the feature is kind of poisoning the whole system, so to actually toggle in it, you need to change a lot of things. And the question is, when doing the feature with the feature toggling, and the cost would be, let's say, twice time more than just implement the feature without feature toggling, how do you deal with such situations?
I think there's a lot of context in there that I don't have, but I will say that almost always, I think if you can get to the point where feature toggles are just the way you build new software, I think that really helps you a lot. Now the big bang, I was talking about the migration. I don't mind if you build a feature and release it in one go. What I would suggest, and this has been my experience mostly again in consumer software, is that the ability to toggle, if it's something that's interesting and worth building, it's worth being able to turn on and off, if that makes any sense. So, that's, again, you have more context about your particular question than I do, but that's my initial cut on what you're asking. Thank you. Yeah.
Any other questions? One over here.
As you start to split up the shared data services,
Yep.
A lot of systems I've previously dealt with have a reporting layer that pulls from that. Have you got any great patterns for dealing with that?
Yeah, I wouldn't say great, but but the tried and true kind of ETL mechanism, right? So the characteristic of analytic systems is they are comprehensive, they involve lots of stuff, and also they are not typically real time. If it's real time, let's go event driven and just go straight there. But if you've got the classic analytics problem, which is every so often I want to run reports that summarize over a bunch of time, an ETL mechanism where there's an operational database and then there's some transfer of extract, transform, and load, as I'm sure everybody knows, into some other system that's optimized for analytics. That's the standard pattern, which seems legit to me. Yeah.
Time for one more. Anyone else? No? Well, thank you very much for your talk.
Thanks,
Really
everybody.
appreciate it. Everyone give me